All right, this lesson is on evaluating functions. To evaluate a function, you simply replace the x or the input with the value given for x and then solve. So for the function 2x minus 5, we want to find out what the value of f of 2 is. So we replace the x in the function with a 2 and then evaluate. 2 times 2 is 4. 4 minus 5 is negative 1. So f of 2 is negative 1. Next example, it's given that the function f of x is equal to 4x minus 7. So we want to find out what f of 3 is. What is the output whenever the input is 3? So if we replace the x with 3, we get 4 times 3 minus 7. 4 times 3 is 12. 12 minus 7 is 5. So f of 3 is 5. And then to find out what f of 5 is for that same function, we simply replace the x with a 5. 4 times 5 is 20. 20 minus 7 is 13. So f of 5 is equal to 13. Next, we're given the function g of x is equal to x squared plus 5x minus 1. We want to find out what g of 6 is, so we're going to replace the x's in that function with 6's. So first we want to evaluate the 6 squared, which is 36, and then 5 times 6 is 30, minus 1. 36 plus 30 is 66, and then 66 minus 1 is 65. To evaluate g of negative 4, we replace the x's with negative 4's and evaluate. Negative 4 squared is 16. 5 times negative 4 is negative 20. Minus 1. 16 minus 20 is negative 4. Minus 1 is negative 5. And for the last example, we're given a function and we're given the domain. So we're given all the elements in the domain. So we're given each one of the values that we need to input into that function, starting with 4 and then 7 and then negative 2. So when we replace the t's with 4's, we get the following function, following expression. 4 squared is 16. 2 times 4 is 8. 4 minus 5 is negative 1. 16 plus 8 is 24. 24 divided by negative 1 is negative 24. So f of 4 is negative 24. Do the same thing to find f of 7. Replace the t's with 7's. Evaluate. And we get 63 over 2 for f of 7. And then lastly, replace the t's with negative 2's to find out what f of negative 2 is. Once we do all the calculations, we get 4 minus 4 in the numerator. 0 over any number but 0 is 0. So we get 0 for f of negative 2. So for each one of those elements in the domain, the corresponding elements in the range are negative 24, 0, and 63 over 2.